Alright, picture this. We're stranded in the middle of the Arctic, watching our LC-130, a beast of a plane, roar to life and take off without us. The music swells and, yeah, I know what you're thinking. My Kim Kardashian-inspired outfit is stealing the show. Don't judge. It's warm, and it was the cheapest gear we could snag for this frozen adventure. This isn't your typical engineering breakdown because we're not in a lab or a hangar. We're in the Arctic, and the plane I'm about to dive into is right behind me, the LC-130, a rocket-assisted, ski-equipped marvel that's as wild as it sounds. I'm beyond stoked because I'm about to hop on board, rockets and all, for one of the most insane takeoffs you'll ever hear about. The LC-130 is built to thrive in the harshest places on Earth, the polar regions. It's the lifeline for research bases in the Arctic and Antarctic, delivering supplies and people to spots where no other plane could land. Somehow, I convinced the 109th Airlift Wing to let me tag along on a mission to the Arctic, which meant I got to witness a takeoff that's straight out of a sci-fi flick. This C-130 variant doesn't just roll down a runway. It's got skis for gliding on snow and can be fitted with 8 rocket pods to blast off in conditions that would ground most aircraft. We landed at a remote ice core drilling site to resupply scientists, but with temperatures at a brutal 40 below zero, we couldn't linger. The cold can wreak havoc on the plane, so we had to get moving fast. As we taxied, the skis hit mounds of ungroomed snow, and we overshot the skyway. The pilots were fighting to gain speed, struggling to lift the front ski off the ground. Then the moment came, boom, the rockets fired, and we were airborne. This is the wild engineering of the LC-130. Let's talk about those rocket pods, nicknamed JATO bottles, because they're the definition of badass. You might have seen the Blue Angels C-130 light them up at air shows, and it's a jaw-dropping sight. But these weren't made for stunts. JATO, jet-assisted takeoff, bottles were designed to get planes off short runways with heavy loads. The U.S. military even toyed with launching F-84 Thunderjets from trailers using massive rocket pods. The wildest JATO plan? Operation Credible Sport in 1980 during the Iranian hostage crisis. The idea was to land a C-130 in a stadium across from the U.S. Embassy in Iran to extract hostages. They planned to use 58 rocket pods, some pointed forward to brake, others downward to soften the descent, and the rest rearward for takeoff thrust. The plane's structure was beefed up to handle the forces, but during a test, the forward-facing rockets fired too early, blinding the pilots. In the chaos, they triggered the second set, stalling the plane mid-air. It crashed, buckling a wing. A backup airframe was ready, but the plan was scrapped when diplomacy freed the hostages. Our mission wasn't that intense, but it felt way cooler. We flew from Kangerlussuaq, a tiny town in Greenland with the region's biggest airport, where the 109th and the National Science Foundation based their Arctic ops. Our destination was East Grip, an ice core drilling site perched on 3 kilometers of ice. The goal was to drop off researchers and supplies. We had just 30 minutes on the ground, barely enough time to unload. Supplies were shoved out the rear cargo door as we slowed on the skyway to save time. While we scrambled to film, the flight engineers were busy attaching rocket pods to hardpoints under the wings. Each pod has 3 attachment points and the igniter is screwed in by hand. The ignition system is old school, a black powder charge, sparked by an electrical signal from the cockpit, lights up aluminum and potassium perchlorate pellets. The propellant, a mix of metal polymethacrylate and potassium perchlorate, ignites, rapidly heating the rocket's core to sustain combustion. The rocket's circular cavity means thrust builds over time as more propellant burns. Each pod delivers about 67 kilonewton-seconds of impulse force over time. You can calculate total impulse from the area under a thrust time graph. At East Grip, the minus 40 degrees Celsius cold, same in Fahrenheit and Celsius, slowed the propellant burn, reducing thrust but stretching the burn time. I got a warning to get back inside because my face was showing early frostbite. Yeah, it was that cold. The cold messes with solid rocket motors. Lower temperatures mean the propellant takes longer to ignite, burning slower and producing less thrust but over a longer period. The impulse graph at 16 degrees Celsius looks sharper than at minus 60 degrees Celsius, where the total impulse drops slightly because some energy heats the propellant instead of generating thrust. Still, the loss is minimal compared to the energy released. These days, JATO bottles are rarely needed. During our week with the 109th, most takeoffs relied on engine power alone. But at East Grip, something was off? I talked to Chief Pilot Nate Dickinson about what went down. He explained that we'd gone long, overshooting the skyway into fresh snow, which bogged us down. The pilots hit 70 knots but couldn't accelerate further, so they fired the JATO bottles. Unlike a standard runway takeoff with a clear decision speed to abort, skyway takeoffs are trickier. Gross weight and center of gravity, CG, play a huge role. Pilots prefer an aft CG loading cargo toward the rear for better elevator control and faster acceleration. Loadmasters obsess over this, but sometimes cargo or fuel limits their options, making takeoffs a real challenge. Dickinson shared a story from McMurdo, Antarctica, where a fresh layer of snow after a storm slowed the plane so much they couldn't take off after 4 tries. The LC-130 skis, coated in Teflon like downhill skis, still struggle in deep or sticky snow. Pilots assess snow conditions just by walking to the plane, noting how it sticks to their boots or how deep they sink. Beyond the skis and rockets, the LC-130 isn't too different from a standard C-130. The big modification is the hydraulic system, beefed up to handle the massive actuators in the skis. These let the plane land on regular runways with wheels peaking through the skis or on snow with the skis lowered and rotated under the wheels. After landing, the skis are raised to avoid freezing to the ground. The skis are wide to float on ungroomed or partially groomed snow, unlike thinner skis for groomed slopes. Snow depth, wetness, and texture all affect takeoff, creating friction that slows the plane. On regular runways, pilots use flight computers to calculate takeoff parameters like flap angle based on altitude, runway length, temperature, and weight. Flaps, those wing extensions you see on commercial flights, boost lift at low speeds. But on a skyway with unpredictable snow, the C-130's flap settings are more art than science. Dickinson explained they start at 50% flaps, standard for C-130s, but adjust on the fly. If they can't get airborne, flight engineers tweak the flaps, sometimes to 100% for max lift or even 0% to reduce drag. The goal is to hit 50% by the skyway's end for a normal takeoff attitude, but 100% flaps is a last resort. It gives extra lift, but risks losing control if an engine fails, as the ailerons might not counter the asymmetric thrust. Pilots train for this in simulators, but it's a hairy situation. A nightmare scenario hit an LC-130 in 1971 at Antarctica's D-59 field camp. After a resupply, 2 JATO bottles broke free on takeoff. One smashed into the number 2 engine's tailpipe, and another hit the propeller, with debris taking out the number 1 engine. With no power on the left wing and full power on the right, the plane yawed hard left. Pilot Ed Gabriel leveled it before impact, saving all 10 aboard and earning an air medal. The crew survived in Arctic shelters for 3 days until rescue. The plane sat buried in snow for 16 years before being dug out and flown home in 1988. The culprit? Paint buildup on the JATO mounts from a refurbishment, which prevented proper locking. About 256,000 JATO bottles were made by Aerojet, but they're out of production and the Air Force is running low. Modern LC-130s rarely need them thanks to upgraded propellers. Older models had 4-bladed props, later 6, but today's have 8-bladed composite props from Collins Aerospace. Propeller blades are like wings, generating thrust, lift with more area. Increasing diameter wasn't an option due to ground clearance and tip speed limits below 0.9 Mach. Instead, designers added blades and adjusted chord length. The new composite blades are half the weight of aluminum, stiffer, and use rounder airfoils that increase the stall angle for more thrust on takeoff, about 20% more, cutting takeoff distance by 300 meters. During cruise, the blades feather to a lower angle for efficiency. One surprise was the navigator's role. I assumed GPS had replaced old-school radar, but navigator Major Jefferson Wood explained why it's vital. In the Arctic, with no air traffic control and endless white landscapes, the radar picks up structures and skyway flags from 50 miles away. At East Grip, with its 10,000-foot skyway marked by flags, the radar lights up like a Christmas tree. In low visibility, like the 200-meter cloud cover we hit, the navigator guides the pilots with headings and descent rates as visual cues are non-existent.